Enigma and Lorentz and some of the other codes were broken because of human errors. They were basically unbreakable at that time. It was just stupid humans who gave it away, and the Germans gave it away with gusto. Anyway, so this part of is about the breaking of the German Lorentz cipher, and there's a picture of the Lorentz cipher machine. We've got one of these. It's down in the museum in B Block, and you probably haven't got time to see it today, but it's down there in a glass case, and it was actually belonged to Marshal Kesselring and was captured just outside Berlin at the end of the war. And so that's down there. So that's the Lorentz cipher machine. And I said that was very important because it was literally used by Hitler to his generals. So very important messages being sent incited on that. And it was a method of enciphering teleprinter tablets, 5-hole punch paper tape, pre-war commercial method of sending messages in the Bodo or Murray teleprinter, international teleprinter code there. And that's what the Lorentz machine enciphered. And then when it was enciphered, it was transmitted by teleprinter code. And there is a message coming in there on that receiver, and that is actually a teleprinter message, and that is coming from Germany. Not in World War II, but now. There's a very convenient German weather station which still transmits its weather reports by teleprinter. We found it, and the metal is showing what television signals sound like. It's pretty obvious that human beings can't read teleprinter. You can read Morse code, you certainly can't read that. And so what they had to do in wartime was to ink pen record the signals on a thing called an undulator. There's a strip of paper tape there with an ink pen recorder, and that records the 0s and 1 bit patterns coming off of the radio receiver there at high speed, and then somebody, usually a poor girl, would sit and read those bit patterns in order to get the letters of the ciphertext that was being intercepted. Quite a difficult operation. It was made even worse by the fact that the final paper tape that went on to Colossus, which you'll see in a moment, that had to have less than 6 errors per 1,000 compared with the original radio transmission, otherwise Colossus couldn't break it. And that's a challenge even today. So in wartime, everything was done in duplicate, 2 radio receivers, 2 ink pen recorders, 2 girls independently reading the bit patterns to get the letters, and then transmitting those letters independently to Bletchley Park, and finally, in Bletchley Park, 2 girls punching 2 paper tapes and comparing them. And it was either hooray or yuck, but it was a very difficult job to achieve that accuracy that they did. Now, the Germans began to use this top secret cipher machine in early 1940. We intercepted some signals, realised they were teleprinter, realised they were in code because it was gobbledygook, and knew nothing about this machine until the Germans made one horrendous mistake. This was a German operator had a long message of 4,000 characters to be sent from Athens to Vienna. So he correctly set up his brand new top secret Lorentz cipher machine and turned all 12 wheels to a particular set of wheel start positions, and then transmitted by radio a 12-letter indicator, which was a coded way of telling the operator at the other end the exact settings he was about to use, because both machines had to be synchronized. They got them synchronized. He then keyed in 4,000 characters of German text by hand, and when he got to the end of keying it in, the German operator at the receiving end said, "I didn't get that. Send it again. Not a good idea for a secret message." And the German operator at the sending end compounded it by saying, "Well, nobody can possibly break this brand new top secret cipher machine, just reset it." Forbidden to do that. You never reset a cipher machine. But he did. He turned all 12 wheels to exactly the same wheel start positions he just used on the first failed transmission. And then, because it was his procedure, transmitted exactly the same 12-letter indicator which told the world he'd done this stupid thing of putting the machines back to the same start position. And then he began to key the message again by hand. And when we finally decrypted it, the message begins with the German phrase, Spruch Nummer, message number. Not a good thing to begin every secret message, they did. The first time he keys in Spruch, N-U-M-M-E-R, rest of text. Second time he keys in Spruch N, I am thoroughly annoyed and pissed at this, N-R. Now N-R in German is a shortening of the German word Nummer, just like our N-O in English is a shortening of our word number. So it shortened the entry by 4 characters to save its fingers, which meant the text was shifted by 4 characters from that point on. And when he got to the end of the second translation, it was 400 characters shorter than the first one, where he had been shortening words down the text. But because the machines had been reset, they were generating the same key stream on both transmissions. Right? The interceptors in England realised, indicators saying, possibly boo-boo, sent post-haste to Bletchley Park, arrived at the desk of John Tiltman. Now John Tiltman had already worked out, he was top codebreaker here, he'd already worked out this was technically what was known as a Vernam additive cipher. And that was a very simple but very powerful way of enciphering teleprint characters invented by Gilbert Vernam in America in 1918. And what Gilbert Vernam realised was, if you took the bit pattern for a letter A in the Bodo code, which on the tape is hole, hole, no hole, no hole, no hole, or in modern speak 1, 1, 0, 0, 0, if you took the bit pattern for letter C, if you now add those bitwise modulo 2, right, 1 plus 0 equals 1, 1 plus 1 equals 0, and so on, you get another character. And what Gilbert Vernam realised was this is a cyclic set because of the modulo 2 addition. So this is a secret character you want to send to somebody else. You add your own private obscuring character to it and transmit the result as the cipher character. At the other end, the intended recipient gets the cipher character, knows what this obscuring is, adds it, peels it off, and reveals the plain language text. A very simple but very powerful additive cipher. Now, Tiltman thought these transmissions they were just intercepting probably was an additive cipher, and so a Vernam cipher. So he reasoned he could now write out these 2 ciphertexts letter by letter, one above the other, and now manipulate those in pairs because the key stream was the same on both transmissions. So when he started to go through that, he got through Spruch, he got to Spruch N, found the distance between U and R, guessed what it was, and he was in. And after 10 days of hot brain cells, John Tiltman had worked out both of those German language texts completely, from the combined mistake of resetting the machine and then keying the second one just slightly different to the first one. That's what gave it away. And then he was able to add the language text, character by character, modulo 2, to the ciphertext, and reveal 4,000 characters of pure key stream generated by this brand new, top secret German cipher machine. And that was given to a young gentleman called Bill Tutt, and Bill Tutt was a brilliant mathematician. And Bill Tutt, in the research section here in Bletchley Park, over the next 2 months, analysed that key stream and produced the logical diagram of the Lorentz cipher machine from that one mistake the Germans made. Now, I give lectures all over the world about code breaking in Bletchley Park. About 3 months ago, I gave this lecture to a room full of hardened modern computer security specialists. At that point I said, we don't make those mistakes nowadays, do we? And they all went white and reached for their sick bags, because that gave us the entree, literally, into the communications from Hitler to his generals and the whole of the German High Command. One mistake. And so now, having got the logical structure, we could now build our equivalent. And here it is. This was known as the fish traffic, the Polish traffic. This is the tunny machine, the German tunny machine, and this is our tunny machine here. So this is logically exactly the same as the unseen Lorentz cipher machine, but built using post office user selectors and relays. So here's the 12 wheels here. Here's the patterns on the wheels and the wheel start positions. So now, when the code breakers had initially, by hand, worked out the settings a German operator had used on a particular intercept, they could now plug those settings up on this machine here, and we could now and that has now configured that to exactly the same settings the German operator used to encipher the message you just intercepted.